Welcome back, guys. We're just making another little video. There's some work in an exercise to help you with prime numbers. I think the chapter title is something like number properties and patterns. So this is a really good time to stop and actually look for those patterns. And we're going to do some work on prime numbers, and we need to know a couple of things, like prime numbers are positive whole numbers with two distinct factors. Those factors are the number itself and 1. So whatever, you might hear people say, only 1 and that number go into it. That's what we mean. All right. And if we had building blocks, and we know prime numbers get pretty large, and little caveat, but I think of it as one row of those numbers. All right. And that blows my mind sometimes, to think of some stupid big prime number can only be arranged in one row of that number. So that's the work we're doing, and there's a couple of things we need to sort of understand here, that prime numbers are the building blocks of all other numbers. You're going to see that work shortly, where we're going to decompose numbers into their prime factors. And there's something else we need to know. Like, we know the numbers are infinite, so they don't stop. So by extension, the number of primes that are present are also infinite. We don't really know how many primes there are. Okay, we're still busy on the search for trying to find the largest one for some reason. Okay, so this is really interesting work, and there's a lot I can show you. I'm just going to jump behind the light board and we'll talk again soon. Okay, I've just set up the board here. We're working on primes, and I want you to understand that the primes are building blocks of all numbers. So what I've got here is, I'm thinking about one row of whatever that prime number is. Okay, if we wanted to make it 13, 13's prime, one row of 13. That's the only way that we can build 13. So there's another key idea I want you to think about here, and that's the idea of a sieve. And here we are. You can think about how sieves normally work, where if we put flour in the top here, we would let the flour pass through into the bowl here and catch the flour, and possibly in the sieve, all the bugs and everything else that we don't want to eat or bake with will be left behind, all the little stones. Well, with numbers, we're doing exactly the opposite. The sieve is catching what we need, and instead of flour, let's change this to numbers. And it's only whole numbers. And we're going to catch the prime numbers in the sieve. That's all we need. Okay, and we're just going to discard all the other numbers for a moment. We're not interested in them, we're only interested in primes. So the thing is, with primes, we can only have one row of something. Okay, so with that in mind, I'm going to ask you to make a list of the numbers from 1 to, say, 100. Okay, perhaps we could maybe even give you a bit of paper with them all set out in a grid. Okay, and whatever way we choose to do it. Now, it's important to remember a few things. 1 is not prime, and it's not prime for a good reason, because we can build any other number by just adding 1 to it. We can think of what number we want, add 1 to it. So really, the first number that we catch with the sieve is 2. 2 is even, and it's prime. Now, every other even number greater than 2 will not be prime because 2 is a factor. So here's something interesting with your grid or your numbers. You can circle 2 and then you can cross off every other even number. So any number ending in a 0, a 2, a 4, 6 or an 8, you can cross them off. And with one little fact, you have halved the work that you need to do. So we're building a list here, and this is all about lists, and we're building a list of prime numbers here, and 2 is the first number on our list. Now when we're thinking about 3, there's only one way to build 3, one row of 3. So we catch 3 in the sieve. We also catch 5 in the sieve, and now this is an interesting one. And it's an easy one. Because 5 is prime, any other number ending, we've already crossed off the ones with 0 on them, but any number ending in 5, we can cross off our list. They're gone. Okay, so from this point forwards, in our sieve, we're going to let any other number ending in 5 drop through the sieve. We don't want to catch it. So we need to include 7 on our list, and this is important. The next one is 9, and this might catch a few who want to leave it in the sieve, but it's got to drop through the sieve because 9 is actually 3 times 3. It's a square number, and we're going to do some more work on squares later on. That's not on our list. Okay, so next on our list is 11. I'm dropping down here, 13. 15 is not going to, we're just going to discard it. 15, so 17's on our list, 19's on our list. 21's not on our list because 21 is 3 times 7. It is the product of 2 prime numbers. So just be careful with some of these. 23's on our list, 25's not, 27's not because that's a multiple of 3. 29, 31 is the next one on our list. And with this idea of a sieve, you can sieve out all the primes up to 100. You could even go further if you wanted to. Now, it's important to remember once a prime number appears on this list, we've just got to be really careful because we might hit a number like 51, and 51 is 3 times 17, and so that's a product of 2 prime numbers. So 51 won't be on the list. Look out for other squares, and right near 51 there's 49, but that's 7 times 7. It's a square number. So 49, even though it looks prime, it's not on our list. So I'm quite prepared for a few mistakes, and we'll share our lists and we'll come back and settle on the final list. Okay. No, I'm not going to write out a list of all the primes here, but I want to spend my time in this video, and hopefully you've paused it and you've gone away and generated your list. You've done that work for me. Now you're back and I've got something else to explain to you. And hopefully you notice this. I'm just going to write out some multiples of 6. And perhaps this is enough to get you started on looking for a pattern. So they're the multiples of 6, and I'm writing something either side of them. I'm writing the numbers either side of them, And look what is happening here. Now, it's not always the case. I understand that. But in most cases, what do we got either side of a multiple of 6? We have a prime number, 23 and 25. Now, 25 is not prime, but it is the square of two prime numbers. Okay, and you might be wondering, what about 2 and 3 back here? What about 2 and 3? They're both prime. Look at this. 2 times 3 is 6. This is a very important building block in the world of numbers. 2 times 3 is 6. And have a look at what's either side of these numbers. I'm looking here, extending out the list, and I've got 29 that's prime, and I've got 31 that's prime. So see if you can see if this pattern works out for you. What are we proposing here? We're proposing that primes are either side of a multiple of 6. Okay? Now, there's something that we can do here. If it's not prime, if that number is not prime, like this is a square of primes, prime numbers here. Okay, if it's not prime, have a look at its factors. Okay, I might have enough space here to do 36, and we've got 37 that's prime. That's okay. Look at 35. 35 is not prime, but I'm going to build 35 as 5 times 7. And if we look at the factors of 35, they're 1, 5, 7, and 35. Technically, even though this number is not prime, it is what we call a semi-prime number. Okay, not quite prime. Close, but not quite, because this is the only way you can build 35. Okay, so have a look at that now, and this is where I'll end this video, because there's a lot of interesting work that we need to discuss.